Hello, this is a lecture that I put together for you simply to use the confidence and sample size calculator that I made for you in Excel. First thing I want to note is down at the bottom you should have 5 tabs. The confidence interval for Z when the sample size is greater than 30. Confidence interval, for T when the sample size is less than 30. Then you've got a confidence interval calculator for proportions. And then you've got a sample size calculator and a proportion sample size calculator. All of these things in here. And I've got some practice problems. Now you don't have access to these, but I've put them here just so that it's easier for us to take a look at these problems and work a few of them. The first two problems are looking for a 95% confidence, and all they give you is a N of 51 and an X of 27. This is a proportion problem, actually. So what we've got is the proportion is 27 out of 51. So let's go to the confidence interval for proportion. So 27 out of 51. My sample size would be 51. My sample proportion. If this is a fraction, you just simply type an equal sign. And let's see, it was 27 divided by 51. When you enter a fraction, you can easily do that by just saying equals and then the fraction. In my case, 27 over 51. Hit the enter key. Now, it gives me the 99, the 95, the 90, the 80, and at the 80 there, I could change that. As many of you know, I have dogs running around all the time. I love dogs, and they decided they needed to help with that lecture, so I had to put them out there for a minute. So I have my sample size. The sample proportion was 27 out of 51. I could find any confidence here on the green one. In other words, I could find the 75% confidence interval, and it would be right here. But my 95% confidence interval looks like it's 392 to 666. Oh, so let's go and see if this is a choice here. 392 to 666. So I would definitely choose C for that one. I don't know if I can insert something and if it'll let me circle this. I don't need to. Let's see. It'll let me do a shape. Well, maybe I'll put a star there. So C was my correct answer. I'll put a star right by the C. How's that? My next problem, it says N equals 97, X equals 46. And they want us to find the 98% confidence interval. I like this one. 97, 46. So I'm going to go down to the confidence interval for proportion. 97 is the sample size, and I always forget, I have to look back and forth. 46, so 46 over 97, so I'm going to type equals 46 divided by 97, bazinga. And they want the 98% confidence interval. We've got 99, 95, 90. I'm going to have to type it in, and you know we can do it. 98%. Click the enter button and yell bazinga. All right, so the confidence interval looks to be, if I were to round this to 3 decimal places, 356 to 0.592, 356 to 592. Oh, there it is, B. Let's go ahead and choose that. I'm going to put B. Going to mark B. So we nailed that one. You see just how easy these are. Let's look at problems 3 through 6. On these, we are actually looking for a sample size. They've given us a margin of error, a confidence level, and tell us that P hat and Q hat are unknown. You see these frequently. In other words, you don't know the proportion. So real easy to do these. First of all, this is asking for a sample size. Gives us a margin of error for tenths, hundredths, thousandths, 4 thousandths, confidence level 95%. So 0.004, I'm going to go to proportion sample size. Margin of error 0.004, so I'm going to type that in. 0.004, confidence level is 95%. And if P and Q are unknown, we use 0.5 here. I'm finished. The sample size is 60,023. Let's see if we nailed this one. 60,023. We nailed it. All right, let's put a star by that. See where my star is. Make one, right? Put it right there. So we nailed that one. That's our answer to number 3. Number 4, margin of error 0.015. Confidence level 96. P and Q are unknown. All right, let's find that sample size. 0.015 is the margin of error, 0.015. Confidence level in this case was 96%, 96%. P and Q were unknown, so I put a 0.5 there. The sample size would be 4,687. Let's check that out. Is that an option? 4,000. Oh, goodness gracious. Too easy. Let's just mark that answer. The next one, we've got a margin of error of 0.01. Confidence level of 95%. From a prior study, we know that the population proportion, or P, can be estimated by the decimal equivalent of 52%, which would be 0.52. So my margin of error is 0.01. Let's find that sample size. Oh, you know, anybody that's been in a classroom knows I have to look back and forth. 0.01 is the margin of error. 0.01. The proportion, they gave it as an estimate of 52%, so I put in 0.52. The confidence was 95%, so I type in a 95. Don't ever mess with the red bar. It's just there for you to see the Z value. It says I need a sample size of 9,589. Let's see if that's a choice. A bazinga. We nailed it. It's choice A on this one. Too easy. Too easy. On number 6, margin of error, 0.05. The confidence level is 99%, and P can be estimated from a prior study at 0.15. Okay, we can do this one too. Let's see how many we need. Margin of error, 0.05. 0.05, okay. The P was 0.15. Confidence level, doggone it, I forgot. What did they want on the confidence level? 99%, so I'm going to make this 99%. Bazinga, I need 339. Error, 0.05. P, 0.15. Confidence, 99%, so my answer is 339. Let's see if that's a possibility. Bang! Choice B. And we nailed it! All right, we've done proportion confidence intervals. Proportion sample sizes, let's see what 7 and 8 are. It says, use the given degree of confidence in sample data to construct a confidence interval for the population proportion. Proportion cut off there. We've got a survey of 865 in one state reveals that 408. So this is a proportion. Well, it kind of says that anyway in the question. So my sample size would be 865. My proportion would be 408 over 865. So I need a 95% confidence interval. So 408 out of 865 and a 95% confidence interval. Let's go to the confidence interval for proportions. My sample size is 865. My sample proportion on this one is actually, I'm going to type an equal sign and say 408 divided by 865. Hit the enter button. And I need, what was it, the 98 or 99%? I got to look back. 95% confidence interval. So I look to the right of 95, and it would be 0.438. And if I round that to 3 decimals, 438 to 0.505. 438 to 0.505. Bazinga, it's the first choice. 0.438 to 0.505. Let's just put a little star by that. See how that makes us feel. I bet it makes us feel good. Bazinga, there's my answer, A. The next one, number 8, says when 319 college students are randomly selected and surveyed, it's found that 120 own a car. All right, there's my proportion already. 120 out of 319. We want the 99% confidence interval of the true proportion of all college students. So 120 out of 319. Let's find that confidence interval. Boom. Sample size would be the total 319. The sample proportion would be equal to 120 divided by 319. Hit that button, and we're looking for the 99% confidence interval, so I can look to the right of 99. 0.306 to 0.446. 306 to 446. Let's take a look. 306 to 446. Bazinga, there it is, choice C. Too easy. Let's just put a star. Oh, I messed that up. Grab the star and put it right there over C. So we've answered those two. We've spent about, I don't know, 10 or 11 minutes on this. Let's look at number 9 and 10. Uh-oh. On 9 and 10, it says use the confidence level and sample data to find a confidence interval for estimating the population mu. Okay? Round your answer to the same number of decimal places as the sample mean. Okay. All right, I've got an N of 92, sample size of 92, X bar, which is the mean of the sample of 90.6. They're giving me the population standard deviation of 8.9 and a 99% confidence. Now, first of all, my sample size is greater than 30. It's 92. They've given me the population standard deviation, so I'm going to use that Z. Let's scroll back to a confidence interval for Z. Population standard deviation is known. It's 8.9. Note I am using the confidence interval for Z tab down here at the bottom. The sample size was 92. The sample mean, they gave that to me also. It is 90.6. And they want the 99% confidence interval. So here's 99. I look out here for the interval, rounded to 1 decimal place. Looks like it'll be 88.2. Let's see, that 9 pops that up. 88.2 to 93.0. Y'all remember that for me. 88.2 to 93. 88.2 to 93. Bazinga, we nailed it. Let's put this, let's put a little star by there. It always makes me happy to put a star by that. Boom, right there. 88.2 to 93. Gives it to us. Let's look at the next problem. A sample of 130, all right, sounding like a Z here. I have a mean weight of 21 ounces. All right, there's my X bar is 21. My N is 130. And a standard deviation of 3.0 ounces. They've given me the standard deviation. And they want a 98% confidence interval. Okay, we can do that. Again, this is going to be a Z. So let me scroll down here on my Z. And I'm going to put in the population standard deviation looks like it was 3.0. My sample size, 130. And my sample mean, was my sample mean 21? Boom. But they want the 98% confidence interval, so I have 99, 95, 90, so I need to put a 98 right there. Hit enter and yell bazinga, bazinga. Here it is. Rounded, let's round this to 1 decimal place. 20.4 to 21.6. 20.4 to 21.6. 20.4 to 21.6. Okay, it would be 20 to 22. All right, let's look at that again. They said I wasn't paying attention to the rounding. I'm supposed to round it to the same number of places as the mean, I think. So 20.4 would be 20. Now, let's look back. I want to make sure. So let's round this to 1 decimal place. 20 to 22. So it would be 20.4 would be 20 to 22. 20.38 rounds to 20. 21.6 rounds to 22. So 20 to 22. Let's see if that's a choice. I'm hoping it will be a choice. 20 to 22. Bazinga. Number 10 is D. Let me get a star here and put that by there. Control C. I like putting stars. Paste. Ooh, drag it down here and put it by choice D. 20 to 22. All right. Easy enough. Let's look at number 11 and 12. Oh, this is a sample size type question, but it's a sample size question where they have given us a margin of error, a confidence level, and a population standard deviation. So in this case, we're going to be using the sample size, not the proportion sample size, but the sample size calculator. So our margin of error is $120, confidence level 95%, and my sigma is 593. I jot these down because anybody that's been in the class with me knows that I forget from left to right unless I'm looking right at it. All right, sample size. All right, so I click the sample size tab. Confidence 95%. Error I'm willing to accept is 120. Sigma says 593, didn't it? 593. Bazinga, it looks like I need a sample size of 94. Let's see if that's a choice. A sample size of 94. Boom, B. All right, let's just insert a beautiful star here. Boom, there it is, 94. This is too easy. Next question. How many women must be randomly selected to estimate the mean weight of women in one age group? We want 90% confidence. I'm going to jot that down, 90% confidence. That the sample mean is to within. When they use the word within, that's your margin of error. Margin of error, 3.7 pounds. Of the population mean, and the population standard deviation is known to be 28 pounds. That's my sigma. Sigma is 28. Let's see how many we need to sample. Go to the sample size tab. Okay, need 90% confidence, so I'm going to type in a 90 here. Margin of error was 3.7. Sigma was 28 pounds. Hit enter. Bazinga, I need to sample 155. Let's see if that's a choice. 155. Let's go to number 12. Oh, C. How sweet is that? All right. I'm going to copy this. Control C. Paste. Put a star by answer C because that's it. Now, remember, I've got the sample size calculator set up to round correctly. When calculating a sample size, you always round up to the next whole number, whether it be 154.1 or 154.9, but I've got this fixed. If you'll look on sample size and click on that, look up here in the formula, round up. Does the math for you. It rounds to the correct sample size. So we nailed that one. So far, we are 12 out of 12. Let's look at number 13 through 15. Now, I am traveling, and I do not have my jar to shake, but I might shake my jar on this one. Use the given degree of confidence in sample data to construct a confidence interval for the population mean mu. Assume the population has a normal distribution. That's an important thing that we have to make that assumption, and they have to tell us that. But on these, notice the first thing I see is that my sample size is n. So if the sample size is less than 30, I'm going to be using a t instead of a z. So my sample size is n. X bar is equal to 8.7. S is equal to 3.3, and I'm doing this at 95% confidence. All right, let's kind of look at this. It looks like we're rounding to 2 decimal places on these. So let's go down to the bottom, scroll over to confidence interval for t when the sample size is less than 30. All right, my sample size here, I've got some other things pasted over there I've been using, but that's okay. My sample size is 10. My sample mean, it gave it to me, was 8.7. My sample standard deviation was 3.3. And they want the 95% confidence interval. And they rounded it to 2 decimal places, so it looks like, look to the right of 95%, looks like it'll be 6.34 to 11.06. Let's see if we nailed this one. All right, scroll back over to where. Now, your calculator does not have these numbers down here. It doesn't matter. I set them up so I wouldn't have to be toggling back and forth between a sheet of paper. Number 13. All right, I say the answer is 6.34 to 11.06. Not this one. Not this one. I'm going to go with C, and I'm going to nail it. So let's put a star by that. Come on, star. There she is. All right. So we nailed it. All right, next problem. A laboratory tested 12 chicken eggs. Oh my goodness, we're testing chicken eggs. 12 chicken eggs, that's less than 30, so I'm going to be doing a T here. T as in Tom. 12 chicken eggs, and found the mean amount of cholesterol was 225 milligrams. 225 is my X bar. Standard deviation, or S, is equal to 15.7. Construct a 95% confidence interval. 95% confidence interval. We're going to round this to 1 decimal place. I'm going to make a note of that. I write on sticky notes and stick them everywhere. So let's go back over to the confidence interval for T when my sample size is less than 30. Sample size was 12 on this one. My sample mean was 225. My sample standard deviation was 15.7. And I'm looking for a 95% confidence interval, so I'll look 95. I'll go all the way over here. And this is just the half width there of the arrow. That's mathematically what you would do, but you don't have to worry about that. You just look over here at the actual confidence interval. Looks like it's going to be 215.03 to 234.98. I forget how many places they rounded those to, but 215.03 to 234.98. Let's see if that's a choice. I may have to toggle back and cheat and switch. Oh, they rounded it to 1 decimal place, so I would say it's 215 to 235, because I'm sorry. Yeah, to 235.0. 215 to 235.0. We nailed it right there. It's choice B. Let me put a star by it. Control C. Paste. Again, let's look at it. You say, well, Brent, it's 1 decimal place. 215.0 to 235.0. Yeah, I'll look back. Right here is my answer. 215.0. Yep. To 235, because that 7 knocks that 9 up up, and that 9 knocks that up to 235. So 235.0. All right, so far we have nailed every problem. Let's look at this last one. Looks like this last one, it says, the principal randomly selected 6 students to take an aptitude test. All right. Their scores were 76.5. My pencil is going out on me. 85.2. 77.9. 83.6. 83.6. I tell you what I'm going to do. I'm going to kind of cheat and come down here. Scroll down. And I'm just going to type them where I can see them right here. 76.5. 85.2. You say, Brent, why are you doing this? We got to find the standard deviation. They just gave us some round, rough data here, and I've got to find the standard deviation in the mean. 85.2, 77.9, 83.6, 71.9, 88.6. Let's double check these. 76.5, 85.2, 77.9, 83.6, 71.9, 88.6. All right, we got it. Let's get the mean and the standard deviation. First of all, let me kind of blow this up for you. So I'm going to be finding, let's just get X bar. I'm going to type X bar. And then the standard deviation, which is S, X bar. I'm going to put in parentheses, you know what it is, but I'm going to put in parentheses mean. So here I'm going to say equals average, open parentheses, cover these numbers, close parentheses, standard deviation equals STD. I'm going to double click on stdev.s, cover these numbers, hit the enter button. All right, now you say, how much accuracy do I use? If it is me, if it were me, I would use as much accuracy as I could. So I'm going to write down 80.6167 for X bar. My pencil is going out on me. 80.6167. My standard deviation is 6.22814. All right. Now, how many do I have? 1, 2, 3, 4, 5, 6. So definitely, this is a confidence interval for T, so I'm going to go over for confidence interval for T. My sample size is 6. My sample mean that I calculated was 80.6167. My sample standard deviation was 6.22814. Hit the enter button, and I forgot what confidence they wanted. Let's see. 90% confidence interval. Okay, let's make this smaller so we can see this. 90% confidence interval, so I'll go back over to my confidence interval for T. 90%. Looks like to 2 decimal places will be 75.49. 75.49. 75.49 to 85.74. All right, y'all remember that for me. I'm going to take a picture of it. I'm going to cheat and take a picture of it. That way I'll know it. I'll go back over here. I'm going to paste it here so I can compare it. Where did I paste it? I can't find it. She's on there somewhere. Here it is. So 75.49. Let's see if that's a choice. 75.49 to 85.74. It is D. We'll put a star by it. Control C, Control V. Right there, and you can put this one right down there. You do not have to do that, of course. I'm just doing it because I lose my train of thought. But we have nailed all 15 of those problems. We've used every one of these tabs. We use the confidence interval for Z. We use the confidence interval for T. Confidence interval for proportion. When using that, remember that the sample proportion, if you want to do a fraction, you can easily just type in equals. Remember that your sample proportion is never going to be less than 0, and it's never going to be more than 1. And it's going to be somewhere in between. We did sample sizes when given margin of error and the standard deviation. And then finally, there at the first of these, we also did some proportion sample sizes. Anyway, I hope this helps you a lot. I hope you enjoyed it. Take care now.